Hello, welcome to another video of Code Snippet. So in this video, we are going to go through one of the important topic in Spring Framework. The name of the topic is Spring Transactions, and we are also going to go through @transactional annotation, which is again important annotation inside Spring. So sit back, relax and enjoy the show. So let's first discuss about the prerequisite of this video. So for those who are not aware, we are actually covering a Spring Boot series on this YouTube channel. So basically I have uploaded these many videos. So 13 videos are uploaded. And this is basically the roadmap that you can go through, and we are basically following this particular roadmap. So in order to understand this particular video, you should have understanding of aspect oriented programming. So these two videos at the end I have uploaded for aspect oriented programming, again a very important feature of Spring Boot. So just go ahead and check that out. So if you haven't seen these particular videos as well, it's recommended to go through it. Now let's move to Spring Transactions. So Spring Transactions and transactional annotation, right? So before jumping into transactions, let's understand what are critical operations or critical code sections inside your code, right? So basically code segments where shared resources are being accessed and modified. So let's say there is a chunk of a code or a function where critical resources are accessed and modified, right? For example, let's say there are multiple people who wants to book a flight, right? So basically long weekend is coming, right? People wants to go to Goa, right? Now they want to book a flight over here. And let's say everyone wants a window seat, right? Now, multiple people will hit same request to book a flight seat, right? A window seat. Let's say there is one window seat with ID 1, right? Now, these people are hitting the request to book that particular flight, right? Now, what will happen over here is we will first read the flight seat with ID 1, right? We will check if the seat status is available, right? And if it is available, what we will do, we will update the status to book, right? Now what will happen if the simultaneous requests are coming with 3 users at once, right? And your database, it will read that the status is available. Now the booking status may be updated for all 3 users as booked, right? So all 3 of them will think that, okay, my seat is booked. But when they onboard a plane, there will be a chaos, right? So that situation may happen over here, that there will be inconsistency of your data if you hit the multiple request and try to access a same resource. When multiple requests try to access the critical section, right? So when multiple requests try to access a critical section, data inconsistency can happen, right? So that is a problem that we are trying to address over here, right? And what is the solution on this one? So basically solution over here is transaction, right? What is transaction? Transaction is basically something which helps to achieve acid properties, right? While you are studying, you must have studied acid properties, right? So what are acid properties? Atomicity, consistency, isolation and durability, right? So let's go through it quickly, right? What is atomicity? Ensures all operations in transaction are completed successfully, right? And even if there is any failure, it should roll back the entire transaction, right? For example, let's say this is your friend and this is you, and you want to send some money to your friend, right? Now, let's say you are sending 100 rupees to your friend. You initiated a transaction, let's say 100 rupees got debited from your account, right? Then the request went to bank and bank is transferring that money to your friend, right? But while transferring this money, there is some error. So basically here, some error occurred, right? Now due to this error, the money got debited from your account but never credited to your friend's account, right? So this is basically a problem over here, right? So in such scenarios, if there is some error which is occurring inside your transaction, the entire transaction should be rolled back. That is, the debited money from your friend's account should get credited back, right? So that's what we called as a rollback. So that is basically the atomicity, right? Even if any operation fails, then entire transaction is rolled back, right? So that's how it ensures atomicity, and which leads to consistency, right? Which ensures the DB state before and after transaction is consistent, right? So even if the transaction is failing, the DB state of user A and B is consistent, right? User A had 100 rupees and the money is still there inside your account, right? It's not debited. There is basically no change inside the account of both the parties. So that is basically consistency, right? Then the next one is isolation. It ensures that even if there are multiple requests that are going through, or even if there are multiple transactions that are running in parallel, they do not interfere with each other, right? That means if there are 1,000 people who are sending money to each other, the transactions will be different, right? They will be in parallel. In your application, there may be multiple things which are happening in parallel, multiple transactions which are running in parallel. But even if those are in parallel, each of the transaction is working in isolation, right? Each of the transaction is running in isolated state, right? They are not interfering with each other. So that is basically isolation. And the next one is durability. That means once the transaction is committed, it is committed, right? Even if your system is failed after that, your database is consistent and it is durable, right? Your data will never be lost, or your transaction will never be lost even if there are system failures. So that makes transaction durable, right? Now transaction follows all these ACID properties. That's why transaction is very important, right? And that's why it is very popular and many people use it inside your Spring framework, right? So that is basically ACID properties for us, and our transaction adheres to ACID property. And let's see how transaction actually works now, right? So what will happen, it will just begin a transaction first, then a debit from your A will happen. Let's say a debit from your account will happen, then credit to your friend's account will happen, right? Then if everything is successful, then it will commit, right? Otherwise it will roll back, right? And after that the transaction will be ended, right? Now here this beginning transaction, ending transaction, right? Doing a commit, doing a rollback is kind of an extra thing that we are doing apart from your business logic. Your business logic is just this, right? Debit from A and credit to B, right? Nothing else. This all other code is kind of a boilerplate code for you, right? Now this is what we discussed inside the aspect oriented programming video, that AOP will handle all this boilerplate code and lets you focus on your business logic, right? So let's say now in your application, let's say you have 1,000 methods, right? And each method, if you start handling these things manually, begin transaction, do commit, do rollback, end transaction, then what will happen? It will be kind of a chaos, right? You will have to take care of a lot of things in that case, and you will need to write all those boilerplate code inside all those methods, right? So that will kind of be a problem, right? Now that is when Spring transaction comes into picture, right? You don't need to handle these things manually, right? You just need a transactional annotation. On that method, you just need to annotate it with @transactional and things are done, right? It's as simple as that. Now in order to get started with @transactional annotation in Spring, you will need to add a certain dependencies inside your project. So let's see what dependencies you will need to add, right? So here if you see, this is a kind of a book application that we have, right? So in one of the video we have created this particular book application, right? In the video where I have defined the CRUD services, right? So it's kind of a simple project that we have created. I'll put a link over here, right? You can go ahead and check it out. So let's come back to dependencies, right? So let's go to pom.xml. Let me open that. So here is our pom.xml. So in order to get started with @transactional annotation, you will need to add this particular dependency. What is it? Spring Boot Starter Data JPA, right? So JPA will provide kind of a transactional annotation to you, right? After that, what you can do is you can simply go inside any of the service. Let me see what service I have over here. The book application, right? In service, we have this book service, right? Now let's say I have add book method over here and I want to make it transactional. What I will do, I will just annotate it with transactional, which will come from Spring Framework transaction annotation, right? The moment I do that, the transaction will be applied on this particular method and your job is done. That's it. Nothing else you need to do, right? So let's say this is your critical section that you want to handle. You just need to add a transactional annotation on top of it. Nothing else. And there is one more configuration annotation basically. It is kind of enable transaction management. So what you can do over here is you can do enable transaction management, right? What this annotation will do, it will let you use transactions inside your Spring Boot application. But this transaction is not necessary, right? Basically Spring will auto configure stuff for you, right? You have enable auto configuration inside Spring Boot application. So this and all is not needed. I'm just telling you because if let's say if Spring is not doing this configuration, then you will need to do it basically, right? but Spring will do it, so you don't need to do it explicitly. You can just remove it and just stick to your transactional annotation, right? Now the next thing over here is a transactional annotation can be applied to function level, or it can also be applied to class level, right? Now here I'm applying it to function level, right? Same transaction I can apply to class level as well. So what I can do, I can just do transactional over here. Now what this means is, on all the public methods that you have inside this particular class, on all the methods the transaction will be applied, right? All the public methods only, not private methods, right? So let's say you have any private method over here. Let's say this method is private and the name is get book headers by ID. So some random name I'm giving over here just to demonstrate. Now the transaction will not be applied to this particular method because it's a private method, right? As simple as that. And second thing, you can also apply it on function, right? So if you, let's say you don't have it here, then whatever functions where we have applied @transactional on, those functions only will be transactions, right? So two things you can do, either do class level or do method level, right? If you do class level, all the public methods will be transactional. If you do the function level, only that particular function will be transactional, right? And one more point to add, if you annotate a private method by using transactional, then this is basically of no use, right? Because private methods are not transactional, and even if you annotate a private method with @transactional, there will not be any transactional applied. Okay, why that will happen, that we will see in future, right? So by now you might be wondering how this transactional annotation is working. Just adding some transactional annotation on top of any function, how it is starting the transaction, how it is committing or rolling back the transaction, right? So fair point, right? So transaction management in Spring uses a AOP. If you have seen the last video, you know what AOP is, right? So basically AOP uses a point cut expression, right? And it uses a advice, right? So advice is basically method which runs before or after a certain function, right? Basically, if you see over here, so in the service class, you have this function which is annotated by using @transactional, right? Before and after execution of this function, a certain method will run that is called as advice, and that will be executed based on a point cut expression, right? Which we have seen already in AOP video, so you can go ahead and check that. So basically how Spring works is, it uses a point cut expression to search methods having transactional annotation, right? We have also seen how AOP works internally, right? So at the runtime only it will create all the proxies which are needed in order to execute these methods, right? Now this is how your point cut expression may look like, right? Now within the method which are annotated with @transactional, within the method or classes which are annotated with @transactional annotation will be intercepted and the advice will be called, right? Now what is the advice, right? What is the advice over here? What function exactly will be called before and after this particular method that we are annotating with @transactional, for example, this add book? So that particular method is basically present inside transaction interceptor class inside Java. So it's a kind of a inbuilt class inside your Spring framework provided by Spring, right? And that will have invoke within transaction method, right? Which is kind of a advice. So once the point cut expression matches, it will run a around type advice. So there are three types we have seen: before, after, and around. So around is basically before and after calling your method, a certain method will be called. So both before and after, basically that is kind of a around, right? So that also we have seen in AOP video. So I'll recommend you to go ahead and check that video, because you will not understand this stuff if you have not seen that particular video. So go ahead and check AOP video once, right? That will be helpful for you to understand stuff over here, right? So that is how exactly it works, right? So again, just to reiterate, the methods which will have a transactional annotation, there will be a kind of a point cut expression like that. So methods which are having transactional annotation, the proxy will be created for that. Which advice Spring will run, or which method Spring will run before or after execution of the method which are annotated with transactional. The name of the method is invoke within transaction, which is present inside transaction interceptor class, right? So let's jump into the code and let's see what is happening, right? So this is basically the code over here. So this is a method inside service class. So let's just quickly go through this code, right? And this is kind of a add book method on which we are adding at the rate transactional annotation, right? And here we have a book controller where we have kind of a post mapping over here. So if you see over here, kind of a post mapping add book, right? And we are just calling that book service dot add book over here, which is kind of the same method, which is annotated with at the rate transactional, and there is a repository which is doing kind of save, right? So we discussed about transaction interceptor, right? So here is basically this internal class. This is kind of a transactional interceptor, and here if you see, this is invoked within transaction method. Now basically this particular method will do three jobs. First it will initiate a transaction, then it will invoke your class, then it will commit the transaction, or in case of any exception it will just roll it back. Now let's see. Now here, if you see, if I scroll down here, if you see, it is creating a transaction. So this particular line will create a transaction, create transaction if necessary. So here the transaction will be created. After that, what you have over here is proceed with invocation. So here your method will be invoked, right? After that, if there is any exception, that means if there is any error, then this complete transaction after throwing method will be called, which internally will roll back your transaction. So if I go inside this method, if you will see that it is rolling it back, right? So transaction manager dot rollback. So rollback it is calling and rolling back the transaction. Now let's go back. Now let's say there is no error, so catch will not be executed, and at the end what will happen, it will commit the transaction after returning, right? So what we will do, so what we can do perhaps in order to check is we will debug the application and check. So what I'll do, I'll just remove these debug points for now. We will add it later in order to see the internals, right? For now, let's quickly run this application. So it's already running basically. So let's add a debug point in controller. So we already have that, and I will add one in service as well. And let's go to Postman. Where is my Postman? There we go. So this is basically the same URL that I'm hitting from the Postman, right? And we are just adding this particular book over here. So let's send it. Now it came over here. So it came in controller. Now let's move ahead. Now it came to your add book method basically. But do you see over here in the left side, you will see that there are 16 hidden frames, right? So how we can see over here is probably can just add threads as well. So once I add that, as you can see over here, do you see invoke within transaction is called, right? Invoke within transaction is called, which is basically the proceed with invocation, right? So before that, it started the transaction over here. So create transaction if necessary is already being called over here, right? And it is kind of invoked your method already. Now, in order to see the internals, what we will do, I will add a debug point, let's say here, while it is starting. When it is invoking, we will add one. In catch, we will add one. It will not go here in positive case, but let's add that as well. And at the commit, we will add one, right? So I'll just mute and run it. We will just unmute and run it again, right? So let's go back to Postman. Let's hit it again. Now it came to your controller again. Now let's go one step ahead. Now, do you see this? It came into transactional aspect support class, and it is creating a transaction now. It is running our advice now. Okay, before calling our actual method, which is annotated with at the rate transactional annotation, right? It's calling our advice, which is kind of this invoke within transaction, right? Invoke within transaction. Let's move ahead. It should come to this one, invoke within invocation dot proceed with invocation. Now, if we move ahead, it will go to your actual method, will do all those operations, and it will come back, and at the end, it will go to commit transaction after returning. Now it is committing in the transaction. Now, if I go ahead, the call will go to your client back, and it will just return the result, right? So that's how basically it works. Now, in order to demonstrate what will happen if there is any error, what we can do over here is we can just throw a new, let's say, runtime exception, right? So this is basically the runtime exception I am throwing. I'll just remove this because this will cry now. So I'm just throwing a runtime exception from here and doing nothing else, right? So what I'll do, I'll restart my application, stop and rerun in the debug mode again, right? So application is up now. Let's hit it again. I'll send it. Now it came to your controller. It came inside transactional aspect support. Now it is basically inside your invoke within transaction. Now it is invoking our method. Now the runtime exception has occurred, right? Because we are explicitly throwing that from this particular class, right? Now it is going into complete transaction after throwing. Now it is going to complete transaction after throwing because it got kind of a runtime exception. Now let's go inside this class and let's see what happens if it is rolling back. So let's go, and if I move forward, it is kind of performing a rollback, right? So that's basically how it works, right? So now there might be an internal server error. Yeah, there is an internal server error on the screen because it's kind of a runtime exception that it is throwing, right? So that is how the internals of your transaction works. That is how your transaction works internally. So that's how it will internally invoke your method, right? Internally invoke your advice, right? So basically creating proxy and everything applies here as it applies in your AOP. So again, I will recommend go ahead and check those videos. Very important to understand these concepts. So that is how your transaction is working internally, and it is kind of invoking your advices around the methods which are annotated with at the rate transactional annotation, right? Now by this point you understand what is transaction and how it is working internally, right? There are a lot more things to learn about Spring transactions, right? It is a very important concept and very vast concept. Just to keep things simple, I'll create the videos in parts. So in next coming parts, we will be seeing transactional context. We will be seeing transaction managers, programmatic and declarative transaction managers. After that, there is something called as transaction propagations, which are required, support, mandatory, requires new, not supported, never, nested, right? So these are basically transaction propagations. So you can just go here and add a transaction propagation over here. So here you can add a propagation like this. You can do propagation dot required, which is kind of a default one, right? So that's how you can add propagations. Now what are the propagations that we will see in next videos? After that, we also have isolation levels, which are default, read uncommitted, read committed, repeatable, serializable. All these are isolation level. Same way you can add isolation level as well. So like this you can add over here, right? And after that you can add a transaction timeouts as well. You can do read only transaction as well. So all those things we are going to cover in the next part of this particular video, right? So there will be multiple parts coming into picture of this particular video because this is a vast concept. So that's it for this video. I hope you have fair understanding of transactions, what are transactions and how it works inside your Spring application. If you like the video, hit the like button. Don't forget to subscribe to Code Snippet so that you don't miss the upcoming videos on transaction. Share this video with your friends so that they also have a fair understanding of transactions. So that's it for this video. See you in the next video.